This problem was asked by Udyan Banerjee. I am first explaining the problem. In this problem, there are two generators, they are operated in parallel, and the load demand is this is the load connected. The load demand is S equal to 200 plus J 100, means active power demand is 200 watt and reactive power demand is 100 VAR. To solve this problem, suppose the current supplied by first generator is I 1, the current supplied by second generator is I 2, and the total current is which flows in the load is I equal to vector sum of I 1 plus I 2. This is also vector, these are AC currents, so I am taking it as a vector. Okay. And suppose the voltage across load is this voltage, suppose this voltage is V dash. So, we are going to write equation for V dash. From first generator, V dash will be V dash is equal to V minus, or I am writing it as V minus I 1 bar into Z 1 bar. Suppose this impedance is Z 1, this impedance is Z 2. So, this voltage will be V minus I 1 Z 1. From second generator, the output voltage, the voltage across load will be V minus, this is also vector, I 2 Z 2, and the so these two voltages are same. From here V will be cancelled out, so we will get I 1 bar Z 1 equal to I 2 bar Z 2, and the total current I is equal to I 1 vector plus I 2 vector. This is first equation, this is second equation. So, from first and second equation, we will get value of I 1 and I 2 in terms of capital I. Capital I is current demand for the load. So, by solving these two equations, we will get I 1 vector is equal to Z 2 divided by Z 1 plus Z 2 into total current, and I 2 vector is equal to Z 1 vector divided by Z 1 plus Z 2 vector into total current vector. From here we can observe that the current supplied by first source is directly proportional to Z 2, means if the value of Z 2, if the value of this impedance is high, the current supplied by this source will be less and current supplied by this source will be high. So, if you want this generator to supply more current, its impedance should be low as compared to the impedance of second generator. Now, we got the expression of current supplied by both the generators. Now, the power supplied by generator. The power supplied by generator to this load will be this voltage, the voltage across load into current supplied by first generator. So, we will denote it as S 1 vector, the apparent power supplied by first generator. This will be the voltage across load, voltage across load is V dash, power supplied by first generator is, this will not be equal to, there is one power S is equal to this voltage is V and this is supplying current I 1. So, there will be one power, power supplied by generator 1 will be V into I 1 star, but this power will not be absorbed by load, because there is some impedance here. So, there will be some active and reactive power which will be absorbed by this reactance also. So, what this generator is supplying, that power will not be delivered to load. So, it is better to multiply this voltage to this current. So, this power will be delivered to load which is supplied by first generator. So, we will write it as S 1 bar is equal to V dash into I1 star, and S2 bar will be, S2 vector will be V dash into I2 star. Okay. So, we are taking complex conjugate on both sides in both the equation. So, from here we will get I1 star equal to Z2 divided by Z1 plus Z2 vector star into I1 star, and I2 star will be Z1 divided by Z1 plus Z2 star into I star. Okay. Multiply in both the equation, multiply both sides by V dash. This will be V into I1 star is equal to Z2 divided by Z1 plus Z2 star into, multiplying both sides by V dash, not V, V into I star. So, this will be S1 vector S1, the apparent power is equal to V into I star. So, S1 is equal to Z2 divided by Z1 plus Z2 star into, this is V dash into I star is the total apparent power that is absorbed by the load. So, this is S. Similarly, S2 vector will be Z1 vector divided by Z1 plus Z2 vector star into S. Okay. So, this is the theory behind it. If the total load demand is S, the total apparent power demand is S. So, the apparent power supplied by first generator will be Z2 vector divided by Z1 plus Z2 star into S, and the second apparent power supplied by second generator is Z1 plus Z1 divided by Z1 plus Z2 vector star into the total apparent power demand. Okay. In PS Bimra, this expression is written as S1 bar is equal to Z2 divided by Z1 plus Z2 into S vector, and S2 vector is equal to Z1 divided by Z1 plus Z2 into S vector. But I do not agree with this expression. If we talk about only magnitude, if we take magnitude in this expression, then the magnitude of apparent power supplied by first generator will be equal to, if you take magnitude of this quantity, magnitude of this quantity will be equal to, even if the magnitude of complex conjugate of a number is same. So, the magnitude of this quantity will be Z1 plus Z2, magnitude of this quantity only. So, if we talk about magnitude only, this expression is correct, but if you want to represent apparent power in vector form, you will have to take a star. So, in PS Bimra 7th edition on page number 87 in transformer chapter, this expression is written, but to correct this expression you will have to use a star here. So, by taking this formula, I will solve this question that is posted by Udyan. Hence, S1 will be equal to Z2, Z2 is equal to J1 divided by Z1 plus Z2, Z1 is equal to 1 plus J1 plus Z2 is equal to 1. So, S1 equal to complex conjugate of this quantity, take complex conjugate, and S is equal to 200 plus J100, 200 plus J100. This will be, this is 1 angle 90 and this will be root 5 angle tan inverse of, this is angle tan inverse of 2, take a star of this quantity, and this is 100 root 5 tan inverse 1 by 2. This will be 1 by root 5 angle. This angle will be minus 90, and it will, when it will go in the numerator, it will come with minus sign, and the star of minus sign will be positive. So, this is minus 90 plus tan inverse 2 into 100 root 5 angle tan inverse 1 by 2. Root 5 will be cancelled out. So, S1 vector will be 100 angle minus 90 plus tan inverse 2 plus tan inverse 1 by 2. Tan inverse 2 plus tan inverse 1 by 2 will be 90 degree. Let phi equal to tan inverse 2, and let phi 1 equal to tan inverse 2, and phi 2 equal to tan inverse 1 by 2, then tan phi 1 equal to 2, and tan phi 2 equal to 1 by 2. Tan phi 1 into tan phi 2 equal to 1, then tan phi 1 equal to cot phi 2, tan phi 1 equal to tan 90 minus phi 2, hence phi 1 will be equal to 90 minus phi 2, hence phi 1 plus phi 2 equal to 90 degree. So, if tan phi 1 equal to 2, tan phi 2 equal to 1 by 2, then phi 1 plus phi 2 will be 90 degree. So, from here tan inverse of A plus tan inverse of 1 by A is always equal to 90 degree. So, this angle contributes plus 90, this is minus 90. So, S1 vector will be 100 angle 0, and S1 vector is equal to P plus JQ, hence this will be 100 cos 0 plus j 100 sin 0, hence the active power is equal to 100 watt and reactive power is equal to 0. So, the active power contributed by first generator is equal to 100 watt. Similarly, we will calculate total apparent power shared by generator 2. S2 vector is equal to Z1 divided by Z1 plus Z2 star into S. So, this is 1 plus J1 divided by 1 plus J1 plus J1 star into S is equal to 100 root 5 angle tan inverse 1 by 2. This is equal to root 2 angle 45 degree divided by root 5 angle tan inverse 2 star into 100 root 5 into tan angle of tan inverse 1 by 2. So, this will root 5 will again be cancelled out. This is root 2 angle 45 will become negative and this will become positive. So, minus 45 plus tan inverse 2 plus tan inverse 1 by 2, this is the angle. So, this will again contribute 90 degree and 100 is also. So, the total apparent power contributed by generator 2 is equal to 100 root 2 angle 90 minus 45 plus 45 degree. So, if we write in rectangular format, this will be 100 root 2 cos 45 degree plus j 100 root 2 sin 45 degree. So, this will be 100 plus j 100. So, total apparent power contributed by active power contributed by generator 2 is 100 watt and reactive power contributed is 100 VAR. So, 100 watt was contributed by generator 1 and 100 watt is contributed by generator 2. So, the total load demand will be met, that is 200 watt, and reactive power is only met by generator 2. If we talk about power factor, since generator 1 is contributing only active power, the reactive power supplied by generator 2 is 0. So, generator 1 will share power at unity power factor, and in this case generator 2 share equal active and reactive power. So, the power factor at which the generator 2 is operating will be 1 by root 2. Power factor is equal to real power divided by total apparent power. Power factor at which generator 2 operates will be equal to 100 divided by 100 root 2, that is 1 by root 2. Let us make phasor diagram of this problem. I am taking V dash as reference voltage. So, I am drawing V dash as this, and this is total current, that is I1 vector plus I2 vector. The load demanded by the reactive power demanded by load is positive. It means it is a lagging load. It is also taking active power. So, there will be a resistance, or I can model it as a resistance, and it is taking reactive power. So, here will be inductor. So, this load can be modeled as RL load. So, it is a RL load. So, it will always take a lagging current, and the power factor of that lagging current will be tan inverse 1 by 2. So, this angle will come approximately 26.5 degree. So, since this current is lagging, so this current will lag V dash by this angle 26.5. So, we will move clockwise at an angle 25 degree, 26.5 degree. So, this will be the direction of total current, that is I1 plus I2, and this is V dash. Now, power supplied by first generator is 100 watt with a power factor of 1. So, power supplied by, that means this voltage is V dash. So, V dash, since the power factor is 1, so the phi will be equal to 0. It means there is no angle difference between V dash and I1. So, I1 will be in the direction of V dash. So, I1 will be in this direction. This is I1 vector, this is I1 plus I2 vector, okay. And similarly, power factor for generator 2 is 1 by root 2. It means since generator 2 is supplying lagging power, so it will, the current supplied by generator 2 will also lag its voltage by an angle of 45 degree. Whenever a generator supplies positive lagging power, the current supplied by generator is lagging. Whenever a load takes positive reactive power, the load current lags the voltage. So, here the terminal voltage of generator 2 is V dash, and the current supplied by generator 2 is I2. So, I2 will lag V dash by an angle of 45 degree. So, I am taking this angle as 45 degree and this is direction of I 2. Now, in the phasor diagram you adjust magnitude of, you got the direction of I 2 and I 1 and total current I. Now, you have to adjust the magnitude so that the overall the vector sum of these two current becomes in this direction. Also, the magnitude of apparent power here is 100 root 2 and magnitude of apparent apparent power is 100 here. So, magnitude of I 2 will be root 2 times magnitude of I 1. So, we will draw the length of I 2 which is root 2 times greater than I 1. So, this will be around this is V dash, I 1 is in this direction, I 2 is in the direction of 45 degree. This looks like 45 degree, and yes, this is 45 degree. So, this is direction of I 2 and this also looks like root 2 times greater than I 1. So, this is I 2, this is I 1 and the vector sum of I 1 and I 2 will be equal to the total current. So, we will draw I 1 here and this vector will be I 1 plus I 2. This is root 2 times I 1. Okay. So, and this angle is 45 degree. Now, by the formula of vector summation, if you will calculate this angle, the angle will come out to be 26.5 degree. If this angle is 45 degree, this angle will also be 45 degree. If this is root 2 I, then this height will be root 2 I into sine 45. This height is equal to this height. So, this height will be root 2 I, this length into sine 45 degree. So, the height is root 2 I 1 into sine 45 degree. So, this height is 1. So, this length is 1 and this length will be this length plus this length. So, this length is I 1 and this length will be equal to root 2 I 1 cos 45 degree. So, this will also be equal to I 1. So, the total length here is I 1 plus I 1, that is 2 I 1. So, this length is, height is I 1 and total length is 2 I 1. So, this angle will be tan phi will be equal to height, that is 1, and base is I 1 plus I 1, sorry, this is I 1 and this is 2 I 1, and the phi will be equal to tan inverse 1 by 2, that is 26.5 degree.